The CPU is known as the brain of the computer. Why? Because it performs the bulk of the processing jobs that the computer does is performed by the CPU. And in order to do this, it needs certain components. So we have three components here. And what are these three components? We have register set, we have arithmetic and logic unit, and we have the control unit. So let's see what each of these mean. So first of all, let's see what is a register set. So a register set is a temporary storage which is attached to the CPU, and this is used for storing data temporarily during the execution of the instructions. Now we know that data is stored in the main memory. However, when the CPU wants to execute some instruction, it has to fetch this data from main memory and put it in the registers so that it can access it faster. So there are a number of registers which are available in the computer. So these registers is known as the register set. So it's a temporary storage. Next we have the ALU, which you are familiar with. So the arithmetic and logic unit is responsible for executing the instructions. So for performing operations like addition, subtraction, comparisons, okay, and so on. So the ALU is the one who performs these. And to control all this, that is what instruction is to be executed or data from which register is to be brought, this is controlled by the control unit. So the control unit supervises the operation of the arithmetic and logic unit and also supervises the transfer of data between the register and the ALU. So we can see this in this particular diagram. So you have the ALU, the arithmetic and logic unit, for performing the instructions or executing the instructions, and then you have the register set out here. So the data from the register set is brought to the ALU. The ALU performs the operation and sends the result back to one of the registers. And all these operation is controlled, which data is to be transferred or which instruction is to be executed. This part is controlled by the control unit. Now let us look at little bit into the general register organization. So as I have already mentioned that we need registers to store the values during processing. Even though data is stored in the main memory during the execution of a program, okay, but it takes time for the ALU to get it from the main memory to itself. So what it does is that the data is brought and stored in the registers which are close to the CPU. So it stores values during processing. And why? Because to access memory is too time consuming, so there is a need for faster storage. And these registers, they communicate with each other and with the ALU through something known as the common bus. So there are a number of registers. For example, in this particular architecture known as 8085 processor, in an 8085 processor, we have a number of, you can see here, general purpose registers. Now what is general purpose register? A general purpose register means that you can use it for storing any temporary value during the execution of an instruction. So if you are performing an instruction, say add A plus B, so the value of A will be stored somewhere in one of the register and B will be the other operand, which is again stored in another register. And then the result of this, that is A plus B, is stored again in some other register. So the registers which are used for these type of purposes is known as your general purpose registers. So they are basically used for the purpose for which they are built, that is temporary storage. In addition to these, you also have special purpose registers. So from the name itself, you understand that special purpose means these registers are built only for a specific purpose. So some of these are the the stack pointer, the program counter, the accumulator, flag register, increment decrement register, temporary registers, and so on. So what is the difference between these and the general purpose registers is that these registers can store only a particular type of value. Like, say for example, the stack pointer can only store the value of the top of the stack, that is the address of the top of the stack. Similarly, the program counter has a special purpose, and the purpose of the program counter is to store the address of the next instruction to be executed. Similarly, the accumulator, the flag register, all these, they have special purposes. That's why they are known as special purpose registers. So you cannot use the stack pointer or the program counter or the accumulator to store temporary values.